In section 3.1 we solved one-step equations and we used inverse operations to solve those. Now we're going to kick it up a notch and we're going to look at two-step equations. So these are going to involve two operations, and as a basic rule we're going to first of all use inverse operations just like we did with the one-step equations, but now because we have more than one operation to deal with, we're generally going to have to perform those in the reverse order from how we would normally perform order of operations. So for example, if we look at the equation 3x plus 5 equals 26, we have two operations here. There's a multiplication by 3 and there's an addition of 5. So we have two operations making this a two-step equation. Well, think about what you would do if you knew the value of x and you were going to evaluate the expression 3x plus 5. You would multiply first, then add. Okay? And to solve for these equations, we're going to go backwards. So instead of multiplying and adding, we undo the addition first. So we take the inverse of adding 5, which is to subtract 5. Then we're going to undo the multiplying by taking its inverse operation, which is dividing by 3. Let's look at some examples and see how this works. So our directions are going to be pretty similar to last time. Solve the equation and then check your solution. So let's look at the first one where we have 2x plus 6 equals 8. Notice there's a multiplication and then an addition. So we're going to undo the addition first. So subtract 6, which we can do as long as we also subtract 6 from the other side of the equation. Okay, so we still have our 2x, we haven't touched that, and then 6 minus 6, well, that drops out, right? The subtracting 6 will cancel or undo the adding 6, which is exactly why we subtracted by 6. And then on the right hand side we have 8 minus 6 is equal to 2. So I'm going to rewrite that over here, 2x equals 2, and now we're down to a one-step equation. So we're going to undo the multiplying by dividing by 2. We have to also then divide by 2 on the other side of the equation. 2's cancel, and we get x is equal to, of course, 2 over 2 is just 1. Those are 2's that have been canceled, not x's, by the way. Alright, so then we're going to check that solution by substituting 1 back in place of x in our original equation. So we're looking at 2 times 1 plus 6, and we want to know, does that equal 8? Well, 2 times 1, and now notice we're back to our normal order of operations. Multiplication first, then addition. So 2 plus 6, and 2 plus 6 is indeed 8, so that checks. Right, 7 equals 4y minus 10. So here, focus on where the variable is. It's on the right-hand side of the equation this time. There's a multiplication by 4 and a subtraction by 10. So multiplying comes before subtracting, so working backwards, we undo the subtraction by adding 10. That means we have to also add 10 to the other side of the equation. So now we get 7 plus 10 is 17, and then we have 4y, and then the subtracting 10, adding 10 cancel each other out. Okay, so now we have a multiplication by 4. We're going to undo that by dividing by 4. So the 4's will cancel on the right hand side, and on the left hand side we simply have 17 fourths, which is just fine the way it is. Really hope you get comfortable working with fractions here, even if it's an improper fraction, no problem. Now take that value and substitute it back into the original equation. So we have 7, and we want to know, does that equal 4 times 17 fourths minus 10? Okay, so that's a 7 here. Alright, so when we multiply 4 times 17 fourths, this 4 will cancel this 4, and we're going to have just 17 here minus 10, and 7 does indeed equal 17 minus 10 is 7. So again, it checks. Right, number 3, 20 minus 3x equals negative 10. So here we have a multiplication. That's easy to see. What's a little bit more difficult to see is what are we doing with this 20? Well, really what we're doing is taking negative 3x, so let's attach that negative to the 3x, and then we're adding 20 to that. Okay? Because there's no sign in front of the 20, it's a positive, so you can think of that as adding 20. And we're going to undo that by subtracting 20. That means we also subtract 20 from the right-hand side of the equation. Okay, so the 20 minus 20 will cancel each other out. And now don't forget your sign here. This is a negative 3x equals negative 10 minus 20 is negative 30. All right, now we have our multiplication to undo. Since we're multiplying by negative 3, we'll undo that by dividing by negative 3. So divide by negative 3 on the other hand, the other side of the equation. The negative 3 cancels the negative 3, and we get x equals, and then negative divided by negative is positive, and 30 divided by 3 is 10. And we'll substitute that back into the original equation and see what we get. So we have 20 minus 3 times 10, and we want to end up with negative 10 here. So this is 20 minus 3 times 10. Remember, we do the multiplication first in our order of operations. So 20 minus 30, and we want to know, does that equal negative 10? Well, sure enough, 20 minus 30 does equal negative 10. And again, our solution checks. Right, next. Okay, x over 4 minus 2 equals 10. So here we have a division, dividing by 4, and a subtraction. So we work backwards by undoing the subtraction first. So I'm going to add 2 instead of subtracting 2, means we have to also add 2 on the right-hand side. Okay, so we still have x over 4 on the left-hand side. The subtracting 2 and adding 2 undo each other, and we have 10 plus 2 is equal to 12. And now I'm going to undo the dividing by 4 by multiplying by 4, which means we have to also multiply the right-hand side by 4. So this 4 will cancel this 4 in the denominator, which is exactly why we multiplied by 4. So that now we get x by itself is equal to 12 times 4 is 48. And of course we're going to substitute that back into the original equation and check it. So we have 48 over 4 minus 2. Does that equal 10? Okay, 48 divided by 4 is 12. We still have subtracting by 2. Oops. Equal to 10. And sure enough, 12 minus 2 is 10, which does equal 10, so it checks. Alright, one more. 3/4 m plus 3/2 equals 9. So we're going to subtract first, and we're going to subtract 3/2, which means we have to also subtract 3/2 from 9. Okay, so we still have 3/4 m equals, so notice the adding in adding 3/2, subtracting 3/2 undo each other. And now it would help to convert this 9 to an 18 over 2 so that it matches up the denominator here. 2 in the denominator, 2 in the denominator. So 18 over 2 minus 3 over 2, we keep 2 as our denominator. 18 minus 3 is 15. And now this is 3/4 times m, so we want to divide. We want to divide by 3/4, but remember we can do that by multiplying by the multiplicative inverse. So we're going to take 4/3 times 3/4. That means we have to also multiply by 4/3 on the right hand side. So on the left hand side, the 4 in this numerator will cancel this 4 in the denominator. 3 in the denominator here cancels the 3 here, so that we just have m. And then on the right hand side, you could just go ahead and take 15 times 4 and then 2 times 3, Or you might want to do some canceling first. For example, notice 3 goes into 15. 3 goes into 15 5 times, 3 goes into 3 once, 2 goes into 2 1 time, 2 goes into into 4 2 times. So in the denominator, we just have 1 times 1, which is 1. We don't need that. And then in the numerator, 5 times 2. So for now, I'm going to go ahead and write that 10 over 1, but that just simplifies to 10. Then let's check that. So we have 3/4 times 10 plus 3/2, and we want to make sure that that's equal to 9. So again, we can do some canceling here because 4 and 10 are both even. So this would be 2. 2 goes into 4 2 times. 2 goes into 5. 2 goes into 10 5 times. So we have 3 times 5 is 15 over 2 plus 3 over 2. And we're hoping that equals 9. So 15 over 2 plus 3 over 2, we already have a common denominator. So we simply add the numerators. So we have 18 over 2. And 18 divided by 2, of course, does equal 9. So we get 9 equals 9. And we have our solution. Alright, so good luck with this. And remember our order of operations. And we're going to be working backwards here.